In this video, you'll learn how to develop a simple point-and-click building system in Unity on a 2D grid. It'll be easy to develop because we'll be using the built-in Unity grid and tile maps. Also, we'll add a nice animation for dropping and collecting the loot from the blocks. As a bonus, you'll learn how to create an inventory system, but we'll talk about that later. Hey, it's Terraria here. I know you missed this. So today we're developing a Terraria-like building system and an inventory system. I'm collaborating with another amazing game dev from Coco Code. I'm gonna show you how to develop a building system and he's gonna tackle the inventory. And at the end, you'll even see how to connect these two. So make sure you watch his video after you're done with this one to get the perfect combo for your game. So how does this work? First of all, we'll have the items that have different fields, including the type like a tool or a block, and an action type like mining or digging. Then we'll have two tile maps, one for highlighting the tiles and the other one for the main terrain tiles. Highlighting the tile will also check if it's possible to do any actions on the tile. For example, if the block type matches the tool type, or if the building spot is available. And then do the actions depending on the tool. After breaking a tile, it'll drop a piece of loot. It'll be collected if the player is in range. And let's get to coding. But before we do this, I just want to quickly remind you that all the project files will be on my Patreon page, so if you want to skip rewriting code, you can get them there. First, we have to make sure we have the timemaps package imported into our project. You can find it in the package manager if you select Unity Registry. Also, we will need 2D tilemap extras package in order to get a rule tile. Rule tile is basically a tile that has a set of rules to position different tile sprites. For example, if there is an edge, it'll place a tile with grass on it. You can download the package on Unity's GitHub page. It has more cool stuff in it, and I actually have a video about Unity tilemaps and their hidden features. I see a lot of game devs writing their own grids from scratch, but you know what? Unity, the sponsor of this video, already has a grid system with all the necessary features. Unity tilemaps and grids are versatile tools that can be used to create levels for your game, make a grid building system, or even ease the coordinate conversions in an isometric view. You can create different types of tilemaps in Unity: rectangular, isometric, and even hexagonal. All these grids have methods for converting coordinates from world space to cell positions on the grid, and vice versa. It's especially useful with an isometric view. But that's not all! Unity also has a very handy package called Tilemap Extras. It has rule tiles, which we're gonna be using in this tutorial to create a smooth continuous terrain. No more placing grass edges by hand, let the rule tile handle it. In addition to that, there are animated tiles if you want to create dynamic water, and a random tile brush to add variety to your scene. You also frequently ask me if you can create different terrain levels on a 2D tile map. And the answer is yes, you can. All you need is a tilemap with colliders, or you can use the tilemap in 3D space. That's right, Unity tilemaps can be used not only in 2D projects, but also in 3D. And with the Tilemap Extras package, you get an object brush that you can use to literally paint 3D objects on your map. I have a video where I show you how to use it and even write a custom erase method for it. Unity grid and tilemaps are often overlooked, but that's just if you don't know how to use them. Luckily, Unity provides well-documented pages on how to use them, as well as step-by-step guides in Unity Learn. Now back to the project. I also imported a few art assets for tilemaps. It already has the tiles and the tile palette, but if this is new to you, check out my other video for a step-by-step tutorial. Now that we have everything, we can start by creating a tilemap. Click on the hierarchy, find 2D, tilemap, and choose rectangular. Duplicate the tilemap and call it temp tilemap. Set its order in layer to 1, so it's always on top. We'll use this one to indicate the selection. To the main tilemap, add a tilemap collider, a rigid body, and a composite collider. Check Used by Composite on the tilemap collider, and set the rigid body as static. Next, I created the player. Add a rigid body and collider to it. Also froze the Z rotation so it doesn't fall on the side. Then, an important part, add a tag called player. Now create a few scripts: item, rule tile with data, and building system. Add the building system script to the player object. Open the item script. This item will also be used in the inventory system. Make it inherit from a scriptable object. Above the class, write create asset menu and set the menu name game object item. After the class declaration, create an enum item type. It has two values, building block and tool. Then create another one for the action type. I'll add dig and mine. Go to the item class. Create a public field of type tile-based tile. Create a public sprite image. Create fields for item type and action type. Also create a vector2int for range. This is the range where the player can use the item, whether it's a tool or a block. Now open the script rule tile with data. First make it inherit from rule tile. Then create asset menu above the class declaration. Set the menu name to tiles custom rule tile. In the class we only need one field, a public item. So now the tile will store what item it should drop when it's destroyed. Go back to the editor. Create 4 items. To create an instance of a scriptable object, right-click on the hierarchy, find the menu we created. In this case, GameObjectItem. Initialize the fields. Tile field will only apply if this is a building block. The image is what you'll see in the inventory and what's going to drop out of the block. Next, create our custom rule tiles. You'll see the standard window for rule tile where you have to add the tile sprites and an item. Assign the item. Then create the rules. Brief instructions. Green arrow means a tile can be connected from that side, red cross means it is the edge. To paint with our new tiles, drag them on a tile palette. Then use them like regular tiles. Make sure you're painting on the main tile map. Now that you have both tiles and items, go back to the items and assign the tiles to the tile field on the building block items. Open the building system script. First, write a serialized field for the item. For now it is going to be used for testing here, but you actually have to get it from the inventory. You'll see how to connect it in Coco Code's video. Next, create a few other serialized fields. One tile base for the highlighted tile, one for the main tile map, and one for the temporary tile map. Also need a few private fields, a vector3int for the highlighted tile position, and a bool if the tile is highlighted. Next, create a method that returns a vector3int and called getMousePosition on the grid, and then get the mouse position and convert it to world space right away and save. Then use the main tile map to convert the position you saved. Also change the z-coordinate to 0 and return the result. After this, create a method highlight tile that accepts an item. The item will be used later to check the conditions. Inside the method, create a variable vector3int and initialize it by calling the mouse on grid method. Then write an if to check if the highlighted position doesn't match the mouse position. We're doing this to optimize things. We don't need to repaint the highlighted tile or do any other calculations if the mouse stayed at the same position. In the if, call the method setTile on the temp tile map and pass the highlighted tile position and null. This will erase the previous highlight. Then get the tile from the main tile map. Pass the mouse position to the method getTile, called on the main tile map. For now we'll check if the tile is just present and then highlighted. If it's true, set a tile on the temp tile map. Pass the mouse position we got earlier and the highlighted tile. After this, update the highlighted tile position with the new mouse position. And set the highlighted bool to true. In the else, set this bool to false. Create the update method. In it, check the item if it's not null. Call highlight the tile. Now go back to the editor. Fill in the fields on the grid building system. Assign the highlighted tile and the tile maps, which are pretty self-explanatory, and test. The highlighted tile should appear whenever there is a terrain tile on the tile map. We're good to proceed further. Next, let's add the code to check the range and if the item in hand matches the tile. In the building system script, create a method called inRange, which returns a bool. It accepts a vector3int position A and position B, and also range, which is also a vector3int. In it, calculate the distance between positions A and B. In the if, check if the absolute value of the x-coordinate of distance is greater or equal to the x-coordinate of the range parameter. Write an OR sign and check the y-coordinate the same way. If it's true, return false because it means the grid cell is not in range. After the if, return true. Next, write another method called checkCondition that returns true. It accepts a rule tile with data and an item for the current item. In it, check if the current item type is a building block. In the if, check if the tile is not null. For that, you just need to put an exclamation point before the tile variable. If this is true, return true. I accidentally wrote false, but I corrected it later. This will ensure if the player is holding a block, the highlight only appears on an empty spot. Then in the if-else statement, check for the tool type. In this case, check if there is a tile in that spot and then check if the tile's item action type equals to the current item's action type. If yes, return true. At the end of this method, return false. Now go to the beginning of this class and add a private field of type vector3int called player position. In the update method, initialize the position. Call world to cell on the main tilemap and pass the transform position since this script is attached to the player. Next, go to the highlight tile method. Write an if to check the range. As parameters, pass the player's position, mouse position, and the range you get from the current item. Cast the range to a vector3int. Cut the code below the if and paste it inside of it. Remove the line where we get a tile. Instead of checking for the tile, we're going to check the condition. As a parameter, get the rule tile with data from the main tilemap at the mouse position on the grid, and pass the current item. Also, in the else statement to the range check, set the bool highlighted to false. Go back to the editor and test for different tools. Make sure that a building block highlights an empty spot and a tool highlights a block of the proper type. The next step is creating and dropping the loot. I set up the loot prefab in a way that it has a parent object and a sprite object. The loot object will have a circle collider. It has to be bigger than the object and equal to the radius where the loot can be collected. Make it a trigger. The sprite object will have a sprite renderer, of course, a box collider or any other type of collider, depending on how you want your loot to look like. In this project, it will be a small box. Also, add a rigid body. Freeze the Z rotation so it doesn't spin. Now, in order to create the effect of loot not colliding with itself so it doesn't stack on each other but rather lays on the ground, on the sprite object go to Layers and then create a new layer called Loot. After this, go to the Edit, Project Settings and find the Physics 2D tab. You'll see a collision matrix. Turn off the collisions for loot with loot. Then create a script called loot and add it to the loot prefab, to the object, not to the sprite of course. Open the script. First, write a few serialized fields for the sprite render, box collider, and also a float for the move speed. Also, write a private field for the item. Let's also create a method initialize. It'll accept an item. In it, initialize the item field and with the past item. Get the image from the sprite render and assign the image from the item to it. Next, create an IEnumerator called move and collect that accepts a transform target. In it, first destroy the collider. It is going to be the collider that has the shape of the loop. Then write a while loop. In the condition, check if the transform position is not equal to the target's position. Inside of it, initialize the transform position with the value that returns the method move towards, called on vector3. As parameters, pass the transform position, target position, and then move speed multiplied by the time delta time. Write yield return 0. After the loop, destroy the game object. After this, create a method onTriggerEnterToD. It is a unity method that accepts a collider to the other. I check the other's tag by calling compare tag and passing the player tag. Inside the if, you first have to try to add the item to the inventory, and if it returns true, it means the item was successfully added, and we can play the animation. Start the coroutine move and collect, passing the other transform. Go back to the editor and fill in the fields. Finally, go back to the building system script. First, create a field for the loot prefab. Then create a method called build which accepts a vector3int position and an item to build. In it, just set the tile on the main tilemap, passing the position and the tile from the item. This is also placed to reduce the amount of the items in the inventory. Next, create a method to destroy a block. It'll only need the position. In it, set the tile on the temp tilemap to null. It'll remove the highlight. Set the bool highlight to false. Next, create a variable of type rule tile with data. Initialize it with the tile you get from the main tilemap at that position. Next, set the tile at the same position on the main tilemap to null. After this, convert the position path to the cell center. For this, call get cell center world on the main tile map and pass the position. Instantiate the loot prefab at that position and save the game object. On this object, get the loot script and call the initialize method passing the item from the tile. Future tomorrow turning. I found a small bug here. You have to remove the highlight when building too, so copy these 2 lines of code and paste them in the build method. Next, go to the update method. In it, write another if to check for the mouse input. If it's true, check if the highlight is present. Then, if the item type equals to a building block, call the method build passing the highlighted position and the item. In the else if, check if the item is a tool, and if it's true, call the destroy method passing only the highlighted position. Finally, go back to the editor. Add the loot script to the loot object. Initialize the fields. I set the speed to 4. Next, fill in the loot prefab on the building system. And test! We have the tile selection based on the range and the type of item in hand. If the item is a tool, the block will be destroyed. If it is a building block, it will be placed on the tile map. A destroyed tile drops a piece of loot that can be collected if the player is in range. After you have both the building system and the inventory system, you can watch the connection part in the Coco Codes video. This is how the project will look after the connection. We have a nice inventory where you can switch between different items. The highlight on the tile map changes depending on which item we currently have selected. And if we destroy a block and collect the loot, we get an item added to the inventory. That's it for this video. Thank you for watching. I hope you learned something new. Subscribe and smash that like button. Also, I'd like to thank all my patrons for supporting me and welcome new members, especially Quido and Yuka Kanai. See you in the next video. Bye!